Hello everyone. So today I will talk about ANOVA, and the topic we'll talk on ANOVA will be more in details. So what is ANOVA? ANOVA is analysis of variance, and that's a technique we use to compare. So we're comparing several groups. So you learned ANOVA in the past. We did talk about ANOVA, and what we learned was we run ANOVA to compare groups, specifically when we have more than two groups in our IV. So for ANOVA we need our explanatory variable, or our IV, to be, this is our IV, right? Our IV to be categorical with more than two groups, right? If two groups, what did we use? We used Ttest, if you remember, or independent Ttest, or paired Ttest, or pool Ttest. So that's one thing. Second is our response variable, response has to be, or our DV has to be continuous or numerical. Okay. So and so you have one IV, right? One explanatory variable. One explanatory variable. And one response. Now what you learned in the past was basically an easy way of running ANOVA test, and that was, let's say in this example that we're doing, and it's an example from the book. The example is talking about different variation or variety of types of wheat. So why are we doing this? We're going to produce wheat, and our agricultural research is required to understand which type of wheat is actually creating the lower risk of damage and higher efficiency, faster growth, and that's what we call it yield. So those types of wheat with average yield of higher average yield, those are the ones we are interested in, because if we don't want to have all varieties, we want to see which one is the best or which one creates a higher yield, and that's the one we want to go for. Okay, so to do that we have one IV, one DV, right? The IV is variety or groups. The groups are types of wheat, and our DV is a continuous or numerical variable, and it's yield, right? So I go to fit y by x because I have one IV and one DV, so yield. I want to put variety here. And since I have more than two groups, look, jump automatically is deciding you're going to use a one-way analysis of variance, or ANOVA. We click OK, and the first thing we see here is jump separate the groups for us, and you can see how they're spread. By looking at them, I would say, look, these two groups are these two seems to be higher than the other three. These other three, they're almost the same range. These are almost the same range, but which one seems to be higher? I think endurance seems to be higher, and after that Hatcher, and these three are low. I think the lowest is supposed to be a run L. So we can run the test, red triangle, and we can do it actually in different ways. And let's see, let's do a means ANOVA. Okay, so you run a means ANOVA test, And you can see that we have these graphs, have these plots, and we can also add on the display option. You can add the box plot up there, box plot. So if you see this in the book, it's exactly the same as, and you just need to know how to create, right? So that's my analysis of variance or ANOVA. This is what you learned in the past, right? You learn how to run ANOVA test, and ANOVA is based on Ttest. Write it here. It's based on Ttest, like Z or like T. F is a distribution, and just need to make sure that the p-value is less than 0.05 to reject HO. And what is HO? Let's say what is HA first. HA is there is a significant difference between, or better to say among, groups of IV, right? Groups regarding DV. So groups of IV difference among, it's actually means of, or averages of, means of group of IVs, groups of IV regarding DV, or regarding the mean or average of DV. Maybe we can say groups of IVs regarding the mean of DV, right? So what is HO? HO is the same, just in a negative form. HO is there's no significant difference, right? And there's another way we represent HA and HO. So let's just focus on HO. So if there is no difference, right? If there is no significant difference, that means the averages of different groups are equal. So that means, let's say mu represents average of each group. Mu1, group 1, is equal to mu2, is equal to mu3, is equal to mu k. And mu k is the, we have k groups, right? For k groups. If you have k groups, HO, there's no significant difference. We can also represent it this way. And actually this is in the book, so just want to make sure you know how it looks like. Alright, so in this case that we just checked, you can see that the F value is less than 0.05 for a 95% confidence level, and it's basically telling us that the difference among these groups are significant, right? And you can see it, 19.5, 17, 12, 14, 11. But this is a very basic analysis that we have done in the past. Now we're going into more details, and specifically we're going to use regression analysis to run this type of test. Okay, so let's go to, where is my okay, so let's check facts from here, chapter 26. Analysis of variance, comparing several groups. So we can answer to questions like this. Did agricultural yield go up this year because of more fertilizer or more rain? Or is it a result of temperature or type of seed, right? So we're focusing on the type of seed being used. We're going to use regression analysis with dummy variables to compare the averages of several groups, and this approach is also known as analysis of variance. And here's the main question for us: which wheat variety should a farmer plant? Which wheat variety should the farmer plant? So we have 5 varieties with about 5 available with are being considered: Endurance, Hatcher, New Hills, Ron L, and Reaper. Each variety was grown in randomly chosen plot. So this is important to understand that our samples were selected randomly. That actually help us to have, if there is any bias, if there is any variable negatively affecting the results by choosing random samples, those like lurking variables or confounding variables, their effect will be removed when you have randomly chosen. Specifically, if each group has equal number of observations. If so, of course, normally for each group we don't have equal number of observations, but we designed this experiment in a way that we have equal number of samples in each group of weight, right? And since we have this experiment with equal number of observations, what do we call it? Balanced experiment. So what is a balanced experiment? An experiment where each group has equal number of observations. Alright, so the first step, plot, right? We can create the plot, and we just did that, right? That's right here. That's our plot, and we can see the level is a difference in level. Propose a regression model, check conditions associated with the model, test hypothesis, and draw a conclusion. That's the graph, the plot that we just create. And next step is comparing the groups. So comparing the groups, of course, as I just said, in here said that we're comparing the means, right? Mean of DV. In this case, mean of DV is yield. So we get the average of yield on each of these groups, right? So how do we do that? It's actually very simple. Just we've learned this before. Analyze, tabulate, and this is not the only way you can do it. You can do it in many different ways. I would do it this way. So just go to tabulate, variety here. I can see all of different types of wheat I have, and can see that the samples are similar size, and I need yield n, and after that, let's see if I put n here. Yes, that works. And I want averages, and after that I need standard deviation. So I have all those I need, and if you check, it should be the same answer right here, 19.58, 17.54. That's right. Okay, and the standard deviations are here too, right here. All right. So what's next? And you can see averages are not the same. They seem to be different, but we need a statistical test. We need a statistical test to prove that these are actually exactly significantly different. So relating the t-test to regression, and what is t-test? So t-test is when you have two groups, right? But here we have 5 groups. So what is our strategy here is this. Here's the thing. What is the highest average yield? That's for endurance, right? So we know that endurance is creating a higher yield. The growth is faster, creates more wheat for us. So the thing is, we want to know if endurance is significantly higher than all others, or different from all others, right? the way we say our hypothesis would be, is there a significant difference between endurance, wheat, and Hatcher, No Hills, Ripper, and Ronell? Are they significantly different? So to run a test for that, we can actually create two groups, and we are going to run a t-test, right? So we need two groups. One group is just endurance. The other group is the mix of all others. So to do that, you might need to make a few changes in our data. It's already prepared, but just want to make sure you remember how to create the data. So this is the type of wheat. You can see if the wheat is endurance, it stays endurance. Any other type of wheat is changed to other, right? So we don't see others' names are here, but here we transform them all to others. How to do that? I gave you earlier a video that I explained it in, but let's just explain it one more time. So let's just create the same thing that we have here. Okay. So go on a new column. We want to create a new variable. So double click. New variable is created. And what we need here is to right click on the top of the column and click on the column info. Let's change it to whatever we want. For example, say endurance underline others. Okay, NDU underline others. And so what I need here is to create a formula, and for that I go to the column properties and click on formula and edit formula. This formula is not very difficult. So I want to say if the variable variety equals to, if the variable variety is equal to endurance, stays endurance. If it's any other variable, we change it to others, right? So on the left hand side you have all different functions, but if is a conditional. So go conditional if, right? If variety, if I click here, it appears here. If variety is equal to, type equal, double equal appears, and you type double quotations and then endurance. If you type this wrong, it has to be exactly the same as what we have in the data. And if you type it wrong, then it won't work. Press enter. And if this is the case, right, then what do we type? Again, double quotation, endurance. Else means any other type of wheat, you put it as others. Okay, and that's it. I think that should be working. Apply, click OK, and up here everything seems okay. Click OK. Look, if it's endurance is out. Any other type of wheat is transformed to others. Same thing, exactly the same thing. You can do it for 1 and 0. If it's endurance, put 1. Else, put zeros. For example, D of Hatcher, dummy of Hatcher, right? So if variety is Hatcher, put 1, else put 0. So all you have to do is exact same as what we did here, right? If variety is equal to endurance, put 1, else put 0. So that's for creating dummy variables for the next part. Okay, now we have what we actually needed, and we can run a t-test. And you have one IV, one DV. Yield is still your response variable, or DV, and the other one we just created is undo others. That's it. You have two groups here. You have a continuous variable. You want to compare, right? Seems good. Endurance should be higher. Others should be lower. We want to see if they are significantly different. Red triangle means ANOVA T or t-test. Check these results, and we can also confirm that with the results we have here. If we run a t-test the way that I explained, let's check these numbers. Same numbers. The difference is 5.5, right? We did standard error of 1.785, which is rounded to 79. Confidence level is here. You can see that they're both negative. Considering a two-tailed test, we use absolute of t p-value. That's 0.0037, which is less than 0.05. Do we have that here? Okay, we have that here, yes. 0.0037, right? We have the same results. 0.0037, okay. Then t-test and p-value show endurance has a significantly higher mean yield per acre than the combination of all other varieties. So this was just t-test, simple t-test, right? R square, also R square, 2.2, standard error 4.5, and N is 40. So the t-test can be formulated as a regression with a dummy variable of d of endurance. That is coded 1 if plot is seeded, with endurance, and 0 otherwise. And we can do exactly the same thing for all others. So that's how we are going to create our regression. Okay. So we're going to compare several groups, and we create these dummy variables for dummy of endurance. It's 1 if we have endurance, it's 0 otherwise, and that's what I just showed you here. We already have created this, right? D of endurance. It's 1 if the variety is endurance. Endurance 1. Otherwise 0. For hatcher to hatcher, right? Hatcher. If it's hatcher, it's 1. Otherwise it's 0. If it's no hills, it's 1. Otherwise it's 0. So we created this the same way I showed you for this one, for endurance and others. Okay, so for the next step, we need to understand that we need j-1 dummy variables for j categories. How many categories we have? We have 5 categories, and 5 categories we actually need 4. So 5 minus 1, we need 4 variables here. One variable is going to be considered as a baseline. Which variable do we consider as a baseline? And what is the baseline for? Baseline actually creates our intercept. So we need the baseline to create our intercept. As a result, the lowest, if we check our results here, let's see, let me find this one. Our tabulate, the lowest yield was for run L. Run L has 11.68, right? We want to design our regression formula in a way that run L become baseline, and in fact the value of intercept would be equal to 11.6. So let's do it this way, right? And how do I run that? I want to use I'm going to use a multiple regression, right? And for multiple regression, we use fit model. So yield is still the same response variable, and I need endurance, hatcher, no hills, dipper. I did not select the minimum value run L because I want it to be considered as baseline. So let's just add this here. I want a minimal report to just see what the results that I'm needing. I need them. This is good. Okay, seems to be okay. So click run. Let's see what we have. So the most important things we are looking for here are these estimate of slopes, right? And the intercept here represents run L, and told you before that run L is the lowest average, right? 11.68. 11.68. Okay. So the regression did consider that. And what is D of endurance? D of endurance is dummy of endurance, where if we are using endurance, it assigns a value of 1. For all others, it's using 0. What is D of hatcher? Dummy of hatcher. If we are using hatcher, it gives 1, otherwise gives 0. So 5.8 is created. And to the end, right? Some they have p-value lower than 0.05, 2 of them they don't have. But what's important for us here is what are these values? So let's just write these values on a Word file and just see what we can do with this. So my formula would be estimated yield equals to, so I have 11.68. Let's have 3 decimals. 38, that's 6837, let's put the 4, plus 7.896. That's for endurance, plus, maybe I need to do it this way, plus 5.8, 5.874, 5.85857 for hatcher, and then plus, let's just reduce this. So we have 1.214. That's for new hills, and then plus, the last one is 2.3997. That can be used for the last one, Ripper. Okay, and to make this more obvious, let's just do it this way. Let's do this the red colors. So that we can separately see. Okay, so let's say we want to calculate the estimated, and you remember that when we have a regression model, this estimated value is a mean estimated value, right? This is average. In average, the yield for, if all of these are zeros, and run L is affected, 11.6 is in average. If, let me write it here. So, for example, to calculate, or maybe estimate average yield of endurance, right? For example, to estimate average yield of endurance, endurance will be equal to 1, others equal to 0, right? And in that case, the calculation would be the estimated yield equals to 11.684 plus 7.896 times 1, because endurance is 1, right? And you just need to calculate, and if you calculate this, it actually equals to what we have in our original averages of yield, 19.57 or 58, 19 point, approximately, right? Will be about 19.58. Okay, and this 19.58 is what we had in the past, right? So that is actually explained in the book very clearly. So I just wanted to make sure that you understand the numbers when you read. And then you can do this for another one as well. So it's actually very simple. So estimated. So this was for endurance, right? Type here for endurance. You can do exactly the same for any other case. So if you want to estimate the yield for, and let me just maybe copy this. Just select any of these, new hill. That would be equal to, again, 11.684 is still there, plus, so new hill will be 1, all others will be 0, so it will be plus a 0, plus a 0 for endurance and hatcher, plus for new hill is 1.215 times 1, and that's a multiplication, right? Times 1, and if you calculate that, it has to be equal to average of new hill, right? So new hill average was 12.89. 12.89, so that would be about 12 point, and let me check that, 12.89, or maybe 12.90 approximately. Okay, and it's rounded to 2 decimal points. Alright, so comparing several groups using regression, the variety run L is the baseline, as I said. Analysis of variance or ANOVA, the comparison of 2 or more averages using regression model with all dummy variables. That's what we are exploring. And these are the results. Let's see if we have these results here in regression model. So the R square is 0.358, 0.359. That's great, that's rounded. And the standard error is 4.2 right there. And N is 40, of course. This is what else we have. So if endurance is 1, we can find that y hat is an estimation of yield for endurance, right? That's 19.58 bushels per acre. Since B0 is 11, mean yield for run L, the slope endurance, which is B1, 7.9, is different. The difference between the averages of yields. And you can see that that's what we just calculated together. That's the same thing we just calculated here, right? 11.68 plus 7.896, and that's equal to the 19.58. So that's approximately correct. And what another thing that this is explaining about our formula. So the formula that we just created, this formula is actually explaining it here this way, saying that a regression model that we created, on the left hand side you have estimation of the yield. Mu5 is your baseline, which in this case is a run L. So run L, 11.68 plus. So the slope of the endurance, 7.89, is actually the difference between the actual value of, or average of endurance, minus the lowest. The lowest is run L 11.68, right? So that 7.8 is the difference between, I actually have it here as well, I can show you right here. So that 7.89 is the difference between actual mean of endurance, 19.5, minus the intercept, 11.68, or the lowest, which is run L, right? And the D of Hatcher, the slope of Hatcher, is 5.8. That's the difference between average of the Hatcher itself, 17.5, minus 11.6. That would be 5.8, and so on. Okay, that's what this slide is explaining. Of course, plus epsilon, because there's always an error involved. So one way analysis of variance, this regression model compares the averages of the groups defined by J levels of categorical variables. The observations in this case was 5 groups, right? J was 5. So the observations in each group are a sample from associated population. And equation, of course, like that. Assumptions, errors are independent, have equal variances, and normally distributed. So since we are using a regression model, same as in the past, we have to check all those assumptions, right? You need to check the linearity, you need to check the independence of residuals, equal variances, and normally distribution of residuals. Okay, so inference in ANOVA. Checking assumptions. I believe that we have practiced this a lot, right? So let's look at this first. So let's see how we can create these on JMP. So this is the first one. So I need to go to the red triangle and just need to go to the row diagnostics, and I want, so for checking equal variances or similar variances, right, we use the plot residuals by predicted. Plot residuals by predicted. It should be almost the same thing. It's just they're from left to right. This is from right to left. Okay, it's actually the same thing. And you learn how to create a box plot. Triangle. triangle, and so let me see, we have that here. So we don't have that box plot here, it's okay. Then we have also row darkness. You can check normality by checking the plot residuals by normal quantile. Plot residuals by normal quantile. You can see that almost all of them are close to that center line, and if they're not, they're still in the range of that between upper and lower bound, and that shows normality of residuals. So here you can see it says they're similar within a factor of 0.1 with up to 5 groups. Similar variances condition is met. So we have homoscedasticity here, and normality also. We have normality results here, almost the same thing, and residuals appear nearly normal. And we can also check the Ttest. So Ttest, F value is 4.9 on the top left here, with the p-value of less than 0.05. And F is 4.9, 4.9, you can see that's the significant level. The p-value is less than significant level 0.05. So we reject HO, and that's telling us that this model as a whole is fit to data. And in fact, we can say that there's a significant difference among these. So we are rejecting this, right? This is HO is saying, or null hypothesis is saying, there is no significant difference, and that's why it's showing that they are all equal. But we rejected it, right? We rejected it. That means we're saying that these are not significantly they're significantly different. And on the next step is, let's go down to here. So since the Ttest shows that the mean yield among varieties of wheat are not the same, which variety is the best? Of course, our expectation is to say endurance, right? So now we can run a multiple comparison, and for multiple comparison, I believe we need to go to analyze and fit y by x, and we want to run a actual ANOVA test. So we have yield on fit y by x, yield, and variety. All types of groups are here. Click OK. You can still create your box plots here and run ANOVA test, means ANOVA. Let me see if we have other tests here. Yeah, I think that's the best one. So we can use the means ANOVA. Red triangle means ANOVA. Okay, and you can see the same results here. 4.9, 0.003, and here's the thing, where do we get the rest of the numbers? So down here we have all groups, their numbers, their averages, standard errors, confidence intervals, and so I think we need to go to the red triangle and add a few more information, like comparing pairwise. And what is a pairwise? Pairwise is you're comparing groups 2 by 2. So endurance to endurance, there's no difference. By itself is 0. That's why these are all zeros. By endurance to Hatcher is 2.04. These are actually the same. The absolute values are the same. Hatcher minus endurance is negative, endurance minus Hatcher is positive. The greater one minus the lower one is positive. Lower one minus greater one is negative. So these are all just created by finding a difference. So what I did is go to fit y by x, analyze fit y by x, and yield all the groups together. So we are going to compare group by group, see all averages at the same time and see the differences. Okay. We have ANOVA test. That's the result of ANOVA test. And then we have compare means. Compare means different means. Compare means we can do each pair students T. And let me just close this. We don't need this at this point. We don't need this at this point. So we don't need this, right? So you can see that all the differences here, and if there are significant differences. So we want to see what we are interested in pairwise analysis of differences is the ANOVA test. Test that if all these differences at the same time, all of them at the same time, are they different? But we don't know the results of having a significant different groups. Is it actually because all groups really they're different? So you can see it here up here. You see these circles. You can see that those two are actually similar. Endurance and Hatcher, they have more similarities, and you can see the circles are closer. And these three, they are like more close to each other. These three circles are having more similarities. And checking here, you can see endurance to run L 7.8. That's the difference. Endurance to New Hill 6.6. Hatcher to run L 5.8. And these are significant. Up down to here, these are the groups that their difference in average yield is significant. And most probably because of these is that the ANOVA test is having a p-value less than 0.05 and telling us there is a significant difference between the groups, because you can see that many of them are actually showing differences among each other. And this is showing the significance, right? So they're significantly different. And again, where do we find that this table of comparing all at the same time? You just need to click on this comparison for each pair and check the difference matrix. So that's the difference matrix. That's the same matrix we have here. 2.0, and these are of course rounded, right? 2.04, 5.5 almost. That's the Ripper. So Ripper is one level higher here. New Hills is 6.6. Run L is 7.8 approximately. Okay. And the next, or the last part, the Tukey confidence intervals. So we just ran a t-test here, student t-test, to see if these differences are significant. Tukey is another test that does almost the same thing. 2 by 2 shows the differences in averages and show that are they significant or not. And how to get it is the same as what we just did. Go to compare means, red triangle, go to the compare means, and all pairs Tukey HST. And scroll down. It's actually here. It's actually here. So showing all the averages. You have almost all those reports that we have in the past, but the other difference is that we know that our Let me see if we actually, if you click on that red triangle, we have the difference matrix here as well. So you could get it from the Tukey test as well as the T-student test. Okay. So you can see all those endurance to run L, the difference, and we have lower and upper control limits or 95% confidence levels. If they are both positive, that's telling us that there's a significant difference. But here 0 is included, or p-value is more than 0.05, and they're not significant. So according to Tukey test, 2 of them are significantly different. The rest, they don't show that difference significantly. But according to the T-test, you can see that, or pairwise, you can see that they are more of them are 2 by 2 significantly different.